Okay, so our next topic is we need to find the area between the two polar curves. So that is our next topic. Uh, what we need to do? We need to find the area between two polar curves. So again, if you recall from calculus 2, how do we find the area between the two curves? For example, this is our curve y equals to f of x, and we have another curve y equals to g of x, and this area, it is bounded between these two vertical lines, x equals to a, x equals to b. And what is our problem? We need to find this area. So remember from your calculus 2, the main idea is we are integrate from upper curve minus the lower curve. So this, in this case, it's like if we draw this line from here, this is going to be our upper curve, and this g of x, this is the lower curve. And what is the formula for this? The formula will be equal to integration from a to b, the upper minus the lower curve, f of x minus g of x, and then we integrate this thing with respect to x. But now what do we have here? We have the area between the two polar curves. So think about this. So in this case we have two curves r equals to f of theta, and the second curve is r equals to g of theta, and the theta varies from a to b. As here in this calculus 2 we have defined what is our upper curve and what is our lower curve. Okay, and how do we establish them? So in order to do this thing, you can draw a line passing through the origin, and it passes through the interior of this region, and the point where it leaves the region, that will be our upper curve, and the point where it enters the region, that will be our lower curve. But there will be another method. How can we determine this thing? Because if for example this sketch is not given to you, you are only given find the area between the two polar curves, then you need to determine yourself what are which one is the upper curve and which one is the lower curve, and how do we find the boundaries of the region. Okay, how do we find the boundaries of the region, and what is the formula for finding the area? We have the following formula. Area will be equal to, you need to write half outside, inside it will be equal to from a to b. First we write the upper curve is f, so f square minus the g square, and then we integrate this thing with respect to theta. So this is the formula for finding the area between the two polar curves. This is the formula for finding the area between the two polar curves. So let's do one example. Okay, so what he says here, find the area of the region that lies inside r equals to sine theta. So one of our curve is a circle r equals to 3 sine theta, and outside the cardioid r equals to 1 plus sine of theta. R equals to 1 plus sine of theta. So this is shaded here in this picture. Okay, so our entire region is the following. In this, the area which is shaded here in the blue, what is here, mean this thing, this whole thing. But here we will apply the same technique that we have done before in our previous example. That is, the first thing you need to remember or identify is the following, that is, area is symmetric about the area, it is symmetric about y-axis. Okay, y-axis mean theta is also theta equals to pi by 2, 90 degree. So the area is symmetric about y-axis. So what does it mean? It means that the area which lies to the left of y-axis will be exactly same as the area to the right of this x-axis. So this is the that's why. So this is the region. This is the reason we only find area to the right of x-axis, to the right of y-axis, to the right of y-axis. That is, our theta will vary from this pi by 6 to pi by 2. I mean, this, the y-axis is actually equal to theta equals to pi by 2. So this is the area we are going to find, and after finding this area, at the end we will multiply this area by 2 and we will get the area, mean the total shaded area. Okay, so here if the figure is given to you, you can see here, this is our upper curve, mean the upper curve is this circle, and the lower curve is this one, mean the cardioid, r equals to 1 plus sine theta, r equals to 1 plus sine theta. This is our lower curve, this is our lower curve. But suppose that if this thing is not given to you, okay, if the figure is not given to you, then how can you determine which one is our upper curve and which one is our lower curve? So in order to do this thing, we do the same technique which we have used in calculus 2 to determine which one is our upper curve and which one is our lower curve. So in order to do this thing, to determine which one is our upper curve and which one is the lower curve, I will let you know how can you determine this thing. To determine the upper and the lower curve, how can you do this thing? You need to choose a value, any number. You need to choose a value, any number between this pi by 6 to pi by 2. Mean this is our the values of theta, pi by 6 to pi by 2. So suppose that we can pick theta equals to pi by 4. Pi by 4, it is 45 degree, 45 degree. And then what you need to do, you have to substitute this value of theta equals to pi by 4 in the equation of the circle and also in the equation of the cardioid. And the curve that gives you the higher value of r, it will be your upper curve, and the curve that gives you the smallest value, or that will be your lower curve. That's how you need to determine which one is your upper curve and which one is your lower curve. But here we are given these things, so we are going to substitute everything in our formula. So area will be equal to from pi by 6 to pi by 2, and here we write the square of upper curve, which is going to be 9 sine square theta, minus the square of the lower curve, which will be equal to 1 plus sine of theta square, and then we integrate this thing with respect to theta. We integrate this thing with respect to theta. Okay, so now the next thing is we want to integrate this thing. In order to integrate this thing, first we simplify this, and after simplification we will substitute this and then integrate. But instead of doing simplification here inside the integral, I will do the simplification separately here, and then I substitute the answer in that thing. So what do we have? We have 9 sine square theta minus 1 plus sine of theta square. So it will give us 9 square theta minus, and we are going to expand this thing with the help of the formula a plus b whole square. So that will give us 1 square minus 2 sine of theta minus sine square theta. The first and the last term will add together and it will give us 8 sine square theta minus 1 minus 2 sine of theta. And remember one thing again from the previous knowledge, we cannot integrate this term. We cannot integrate this term. We don't have any formula for this. So in order to integrate this thing, we substitute this thing, the double angle identity. We know that sine square theta, it is equal to 1 minus cosine of 2 theta divided by 2. So then it will become this will be equal to 8 multiplied with this one. 8 multiplied with this one, it becomes 4. Okay, 1 minus cosine of 2 theta minus 1 minus 2 sine of theta. Okay, and then again multiply 4 inside the bracket. So when you multiply the 4 inside the bracket, 4 multiplied with this, and then we have this minus 1, so it becomes 3 minus 4 cosine of 2 theta minus 2 sine of theta, and then substitute this here in this formula. So when you substitute this in this integration formula, so what do we get here? So the area becomes 1 by 2 integration from pi by 6 to pi by 2, and here we will write 3 minus 4 cosine of 2 theta minus 2 sine theta. And the next thing is we will integrate this thing. So this becomes half 3 is a constant, so its integration will be 3 theta minus 4. The integration of cosine is sine. Okay, this is the same formula which we have used above. So this becomes sine of 2 theta, and you need to divide this thing with 2 minus, and integration of sine theta is plus cosine theta, is minus cosine theta, and the minus minus become plus. So here it becomes 2 cosine of theta from pi by 6 to pi by 2, from pi by 6 to pi by 2. And now we substitute these values in, now we substitute these values here. Okay, so this will become half. First we substitute the upper limit, so this becomes 3 pi by 2 minus, here this 2 cancels with this one, so you can write this as minus 2 sine of, when we substitute here pi by 2, 2 will cancel and we get sine of pi plus 2 cosine of pi by 2. Okay, minus 1 by 2, and now we are substituting the lower limit. The lower limit is this 3 pi by 6 minus 2 sine. This becomes, what do we get here? Sine 3 pi by 3, sine pi by 3, sine pi by 3, yes, plus 2 cosine pi by 6. Okay, so now remember few things from your previous knowledge. We know from our previous knowledge what are the values of these things. What is the value of sine pi? We know that sine pi, it is equal to 0. We also know that cosine pi by 2, it is equal to 0. And what about these things? Sine pi by 3. Sine pi by 3, sine pi by 3, it is 60 degree. So that will give you square root of 3 by 2. And what about cosine pi by 6? Pi by 6 is 30 degree, and we know that cosine 30 degree, it is square root of 3 by 2. So now when we substitute these values here, so this term becomes 0, this term becomes 0, and this term, it is kind of cancels with this one. Okay, so we are going to left with these 3 pi by 4 minus 3 pi by 12, and if you take 3 pi by 3 pi by 4 minus, here this 3 cancels with this one and we get 4. So pi by 4, and since the denominator is same, we can write this as 3 pi minus pi, and that will give you 2 pi by 4, and that's equal to 2 pi, that will be equal to pi by 2. Now what will be the total area? So the total area, as we know that we have only find out the area to the right of the y axis. So the total area will be equal to 2 times pi by 2. Now this 2 will cancel and we get the answer pi. So this is the area of this shaded region.